All right, so next up is the idea of an exterior angle, okay? And so the way that the exterior angle works, let's take a triangle like so. All of the angles inside the triangle are interior, obviously. That's interior means inside, exterior is gonna mean outside. So the way that we find one of those is by extending the side from, like extending one of our sides, and then we're gonna measure that angle created outside, okay? So the relationship here, okay, between that interior angle inside and the exterior angle outside, hopefully you remember, this is a linear pair, which means they are supplementary, okay, which means they add up to 180 degrees, okay? So we're going to use that and see if there's any sort of pattern we can find for the sum of the exterior angles. So now we're going to add up all of our exteriors, okay? But first we got to find it. Let's look at a triangle, see what happens, okay? Let's find all these exteriors. So I'm going to take 180 minus 79. I get 101 degrees here. 180 minus 40 is 140, and then 180 minus 61 is 119. Okay, so now what I'm doing is instead of adding up all the inside, which I know is going to be 180, I'm going to add all of these outside angles. So I'm going to do 119 plus 101 plus 140, and that gives me 360 degrees, okay, which is different. Inside and outside are not going to be the same, okay, 99% of the time, okay? So let's look at what happens here. Let's see if there's any sort of pattern now, okay? Now we're going to move on to the quadrilateral, do the same thing, and see what sum we get here, okay? So what do you think? Is it going to be different? Going to be the same? We're going to just add another triangle? What do you think is going to happen? Let's try it. Okay, so 180 minus 124 gives me 56 here. 180, or actually let me change to blue. We've got 56 here. 180 minus 76 gives me 104. 180 minus 89 is going to be 91. 180 minus 71 is equal to 109. Okay, so now just like before, we're going to add all of our exteriors. Okay, so we knew the inside of a quadrilateral is going to add up to 360. Let's see if there's a difference here. Let's see, 109 plus 56 plus 104 plus 91. Interesting. We got 360 again. Okay, but the triangle was 360, the quadrilateral was 360. Okay, go ahead and do that exact thing. We got a couple more. Let's test this a little bit more. We have a pattern maybe, but maybe it changes depending on something else. Okay, so go ahead and try the pentagon and the hexagon, and then come back to the video. All right, so the pentagon, if you did the work, also adds up to 360. The hexagon, if you did the work, also adds up to 360. So you might have guessed, okay, when we're talking the exterior angles, the polygons will always add up to 360 degrees, or the angles of the exterior angles of any polygon will add up to 360 no matter what. I could say, like a question that I guarantee is going to show up on the test is going to say something like, what is the sum of the exterior angles of a 45 gon? Okay, and you're going to be working through it too quick, and I want you to make sure you're reading the question carefully. If it says exterior angle sum, always 360. Okay, so you're not going to run that through the n-2 formula. It is just 360 no matter what. All right, let's look at some examples. All right, so the only really curveball I can throw with this is to talk about regular polygons. So again, all the angles are going to be the same. If all the interior angles are the same, that means all the exterior angles are also the same. Okay, so number 7 is asking, what is the measure of each exterior angle of a regular hexagon? Okay, so for this one, we know all of the exterior angles will add up to 360 degrees. Okay, we know that. It's a fact. Okay, if we want to know the measure of each exterior angle, we know they're all the same because it's a regular hexagon. All we have to do is divide by the number of sides. So 360 divided by the 6 for our hexagon is, let's see, 360 divided by 6 gives me 60 degrees. So let me visualize what's happening here. We have our regular hexagon, which this is definitely not it, but we've got all of these exterior angles, okay? And if it's a regular hexagon, we run the numbers, all of these exterior angles will be 60 degrees. Okay, because there's 360 degrees for all of them. There are six angles. Divide by 6, we get 60 degrees. Okay, so let's try the 24-gon. Okay, same thing, 360 degrees total for the outside. There's 24 angles, 360 divided by 24. And we get 15 degrees for a regular 24-gon's exterior angle. Okay, so if you want a formula for that, that is just 360 divided by n gives us the exterior angle. Okay, but let's flip things around. Okay, what if instead of giving you the number of sides here, what if I give you the exterior angle instead, like number 9? So it says if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? Okay, so now let's use the formula we just talked about here and let's plug in what we know. We've got 360 divided by n, don't know the number of sides, but we do know that the exterior angle is equal to 12 degrees. Okay, and we've seen something like this. Think about our trig that we did last unit. I'm going to write one down real quick. If I had like something like tangent of 30 is equal to 1 over x, okay? We know how to solve this, right? Remember, there's a quick, just flip those around, and we get x is equal to 1 over tangent of 30, and we could solve that. Same thing's happening here. Our variable is in the denominator. We're going to switch spots. So 360 divided by our exterior angle is equal to the number of sides. Okay, so in this case, 360 divided by 12 gives me 30 sides. Okay, so if you want a formula for this one, okay, let me find some empty space somewhere. We're going to do, let's see, 360 divided by the exterior angle gives you the number of sides. Okay, so if we do this one real quick, now we have an exterior angle of 40 degrees. We do 360 divided by 40 degrees, and we get 9 sides for this one. All right, so that's it for this video. The next video is going to be a ton of examples.